This is part 4 of section 1.5. Let's graph the function f of x equal to 1/3 times the absolute value of x by starting with a library function. In this case, it's going to be the absolute value of x, and do the transformations that we need. Here we have a multiplier in front that's not 1 or -1, so this is going to be some sort of stretch or compress. It is outside of this, and so that means this multiplies the y-coordinate because it is vertical y. Okay, so let's think about some points on that, just on the absolute value of x. Well, the absolute value of 0 is 0. The absolute value of 1 is 1. -1 is 1. I'm going to jump up to 3 is 3. And then -3 is 3. Now, why did I go with 3? Because that's 1/3, and the arithmetic is going to be nice. Okay? So what we do is we take the y-coordinate and we multiply it by 1/3. So instead of 0, 0, well, I still have 0, 0, because 0 times 1/3 is still 0. Multiply this by 1/3, and we have 1, 1/3. We have -1, 1/3. We have 3 and 1. -3 and 1. Okay, so 0, 0 is here. I'm not going to worry about these 1/3. I'll sort of verify it by sight. If it looks wrong, it's sort of like a check, but it's going to be hard to graph that. Then I have 3, 1, and -3, 1. And that is enough for me to get my graph. I know that the absolute value has a point on the bottom. And it looks like this. Okay, now if you go back to where we defined a vertical stretch and compression, here we're multiplying by 1/3. 1/3 is between 0 and 1, so we should be compressing it vertically. And if you imagine taking the regular absolute value function, which would, draw it in real quick, look like this. And you can imagine somebody coming in vertically and squishing it down to get our new graph. That's where this terminology is coming from. Okay, so let's do this graph. I want to graph 1/3 times x plus 1 squared plus 2. Okay, so just at a quick glance, we have a horizontal and a vertical shift, and we're going to have some stretching, compressing stuff. Okay, so we do the horizontal shift first, and again, I'm going to kind of ghost some things in, and it's basically x squared. So x squared is normally here, here, and here. I'm going to move these over 1, left 1 to do that. Okay, so let me draw in a couple more points. Right now, what I have -1, 0, I have -2, 1, I have -3, 4, I have 0, 1, and I have 1, 4. That's after shifting it left 1. Now I need to multiply here. This is outside of our square, so it is a change to the y. Okay, so this is a vertical compression. So I'm going to multiply the y-coordinate of each of these by 1/3. So that gives me the point -1, still 0, -2, 1/3, -3, 4/3, 0, 1/3, and 1, 4/3. So I'm going to have to estimate this. In my math lab, you should be able to Well, first of all, on this type of problem, it's probably just going to give you sliders so that you move things around and it's going to take care of all the nitty-gritty details for you. But if it's not, then you can click on a point on it, and then you should be able to edit the point where you'll be able to just type in these fractions. So don't worry about that too much. Also, if I wanted to, one of my points would have been 3, 9. If I move that left one, then I have 2, 9, and I would also have negative 4, 9. And then if I multiply that by a third, then I get some nicer numbers. And maybe that will help me get a better graph. Okay, so what have I done? I have shifted the horizontal. I have taken care of the 1/3. And now I need to take this and I'm going to move all of my points up 2. Okay, so negative 1, 0 moved up 2 is here. I'm going to go to these because they're nice. 2, 3. Move that up 2. And that's here. Negative 4, 3 is there, and obviously I messed up right here. 2. I can't graph at all. This is crazy. I'm sorry. 2, 3 is here, and negative 4, 3. Obviously I can't count, and I don't know what's going on, except that I'm filming this on a Monday, and it is very Monday. So now we connect these, and you have a solution. All right, so now let's write an equation for the function whose graph is the same as x cubed. We're going to shift it 4 units left. Okay, so if I have x cubed shifted left, that's going to be plus 4 cubed. Stretch vertically by a factor of 3. So vertically by a factor of 3 is going to be outside. Reflected about the y-axis. That means it is a horizontal shift, so I need to put a negative on the inside. And so I'm just going to put this right here, negative on the inside, and then shifted 2 units up. Okay, it's kind of ugly right now. Most of the time we clean this up a little bit, and the answer you will see is y equals 3 times 4 minus x cubed plus 2.